So what we've done is we've added a bunch of new features.
Absolutely amazing.
.NET is a general purpose framework for building all of these types of applications.
You can be productive and code and build your UI quickly.
What?
Hi folks, how are you?
And the home screen shows you the sauna temperature.
And you can see down here on the lower right, it now knows the garage door is open.
Let's jump into the code now.
The .NET community has just always been a great community to be a part of.
This really is a state-of-the-art technology.
You can actually download this right now
And get right to the code.
build some new applications on .NET Core.
Please have a great conference. Ask us lots of questions on Twitter. We're going to be there all week.
Welcome to .NET Conf, day 2. This is 2022. Dustin, I can't believe we're here in the studios together again at .NET Conf.
It's exciting.
It's very exciting. Welcome everyone out there. We are ready for another day of .NET, all the new things coming out, lots and lots of talks. Today, let's start with C#. My name is Mads Torgersen, and I'm the lead designer of C#. I lead this merry band of designers, of which you're one.
I am. My name is Dustin Campbell. I'm an architect in .NET tooling, but yes, I am also on the C# design team, and which is really fun.
Yes, and it wouldn't be the same without you.
Aww.
And today we figured we'd just skip the slides and go straight into code. So if you look at our screen here, we have Visual Studio already showing us the first warnings in our code today, and we're going to try to make them go away like a magic trick.
Excellent. Yeah. So first up, it's tradition that Mads and I in our demos, we start with a very, kind of simple person demo where we have a person class. Now, what's cool about this is that we're using some new features that we've introduced over previous releases. We're using a nullable string there with a question mark, using init-only properties. But there's kind of a downside to this as well.
Yeah. I mean, we really want to make it nice to use object initializers and not have to, do constructors for everything. That can be a little cumbersome.
Yeah.
But something is a little off, which is that with object initializers, up until now, it's always up to whoever's creating the object to decide which things to initialize and which not to initialize.
Right.
And that kind of bleeds through here a little bit, right? Because you see there's some squiggles in there.
Yeah, there's some squiggles here. This is where the blessing of nullable is helping you. And essentially it's telling us that, hey, we haven't declared these as nullable, but there is an implicit constructor that will get called before the object initializer up here is run, before those properties get assigned. So technically, these properties will hold a value of null, and we have said we don't allow that. And this is kind of a stumbling block in some of these cases where I want to use object initializers. So often we try to find ways to work around this, and so users often are doing things that feel unnatural, right?
Yeah, but
you might have to assign it to null just to tell the compiler.
It is. Yeah, but this, now you just move the warning, right? Yes,
so you say null bang.
But now we have a place to put a bang and say, and I know what I'm doing.
Yeah, try and pass code review with that. Not for me. But this is the sort of thing we have to do, and it really is uncomfortable.
Yeah. You might even try to get around it by assigning a non-nullable string to it, right?
Yeah,
do
that sort of thing.
The empty string or something. But you're really just hiding a problem that's still there, which is that the object is not properly initialized. You can get the compiler to shut up about it, but it would really be nicer if you could ensure that it was properly initialized.
Right, and there's another issue here too, which is that the object initializer itself doesn't initialize all the properties I want it to. Like with a constructor, I can be very prescriptive about what things need to be passed, what I'm expecting from the user to initialize the object. And here, even if I assign these to null or I assign these to empty string, I don't really want those, but if somebody's using an object initializer, I can't guarantee that they've actually filled in the last name.
So wouldn't it be nice if you could tell the person creating the object, you have to initialize this. It's required.
Yeah.
And that is
and so we can do that now.
Feature. Yeah.
And so the nullability warning goes away because we're telling the compiler, we're expressing in the language that this is a required property. Therefore, it means that when it's initialized, it is going to be initialized. We don't have to worry about some of these details around this time where it might be null, we've guaranteed that. And so if I do the same thing with last name, then looky there, because I haven't specified last name up here. So it says required member must be set in the object initializer or attribute constructor. Now that's curious. Attribute constructor.
Yeah. So let's celebrate the red squiggle.
Yeah,
here.
yeah. Celebrate
this is
that.
like,
Yes.
Yes. You now expressing a contract.
Yes.
Whose job is it to initialize this property? And unless you put required, it's the class's own responsibility.
Right.
But if you put required, you're pushing that responsibility, that requirement onto the person initializing the object.
Yeah. And so we can correctly initialize it as that contract defined.
Yeah.
Right. Now that attribute piece I mentioned earlier was kind of goofy, where it said attribute constructor, and it turns out since C# 1.0, we've allowed properties to be assigned as optional kinds of for parts of the initialization of an attribute. And so while doing this, it kind of felt like we should also attack that problem as well. Since the object initializers are all about initializing an object through properties, attributes also have a way to do that. It's kind of merged together. So if I were to make this an attribute, you'd see the same error. So we'll just call it an attribute. Yeah, sure, that's a thing. And if I have the same code here, you'll get the same error. And so now with an attribute, you can also do this. It's kind of a nice way of just taking it all the way through the language, but also back to C# 1.0 and improving the experience that already existed there.
Yes. Where now you can actually have the old style of optional attribute parameters also be required.
Yeah. It's fantastic. Yeah. All right, let's move on. This has been a cool feature. I'm really excited about this because it feels like over the course of the language, we are continuing to make these kind of small improvements across initialization and really getting to a place where it starts to really coalesce and feel really good.
I mean, it's been a theme for a couple of releases now to make object initialization flow more naturally, have more expressiveness and more conciseness, and this is another step in that direction.
Well, let's take a look at something else.
Yeah.
We've got C# 11 is full of features, and since we're looking at things that improved C# 1.0 from long ago, there was another set of things that we've wanted to do over the years for many years.
Yes.
That also appear in this language.
So everyone who's had the pleasure of doing math in C# and then trying to abstract over the specific kind of number that you're talking about, you will, even if you just used system.math, you've gone and seen all these overloads. There's an overload for each possible numeric type of, absolute value and so on. And you might wonder, what does the code look like inside of all of those overloads? And it looks exactly the same. But we've had to write it like 12 times or however many overloads we collected.
So just to kind of illustrate this, the demo we have here, there's a function. Again, we're using top level code here, so there's a function inside that. So we have a method that will take an array of integers and just adds them up. Okay.
It's a numeric algorithm. It's a beautiful numeric algorithm.
It is genius. We slaved over this one day. We really toiled over it. Yes. And then we're passing an array in here. And if I run this, you can see that it adds them up successfully, which is great. But now if I wanted to make this work over other numeric types, what if I wanted a different sort of like bytes or doubles or anything?
Yeah, what you really want is...
Basically, I'd have to copy and paste this and do it again.
What we really would want is to make it generic, right? We want to say add all of t, and then, this t, then somehow,
So we're going to return a t, now we're going to take a t array. I guess this is going to be a t.
I think that's
and that'd do it.
So that would be cool if you could do that. Of course, you can't plus random t's and they can't be 0. But, if this was just all about instance members, we would put a constraint on that generic. We would say where t something something. And wouldn't it be cool if we could put a constraint on that is like somehow says that I'm a number I have operators and things that make me a number.
Yeah, so I did that, and I used iNumber, which is new in .NET 7, and when I hover over that, I see now that the plus equals error went away, and in fact there is some interface that has the operator plus that is generic and can be used
this
for
is
this.
magic.
It is magical.
Yeah.
The only problem I have now is I still can't convert int to t, but I know that when I'm doing generic methods, I can dot in and look for the static things.
Well, you didn't used to be able to.
No, you didn't.
On a type parameter.
That's correct.
But now there's stuff in here.
Yeah. There's one that would work if I were a mathematician and really good at math. I would know that additive identity is what I need here.
Yeah.
For the rest of us, we could just say 0. And so now this is completely generic, and if I build and run, it still works.
The sum of those numbers is still 15. But now,
and wait, there's more.
What if you use another kind of number?
Yeah, so right now this is an int of int array, but if I throw a double in there, that will cause the inference of the array type.
Oh yeah, now it's a double array. Yeah.
And now it's calling add all with an array of doubles, and it still works. And if I
now it's using doubles plus and 0.
Yeah. Right. So this is generic math on C#11, and it is driven by really a much larger feature.
Yeah. So this is sort of the domain that we chose to double down on.
I see what you did there.
Yeah, we're not just inting down anymore. We're doubling down.
Yes.
On the like the thing where we took the BCL, put interfaces and everything in, but it's really like a special case of a broader language feature that we added. That is, allowing static members and interfaces to be virtual or abstract.
Right. So let me just I will go to definition on this iNumber type, and we'll see what this has. And this has static members, and these are actually. Interestingly, if you get to how this is implemented, they're just static members. They are default interface members as well. They have default implementations, but this iNumber brings in a whole ton of interfaces.
Look at all those interfaces.
Yeah, there's all sorts of things, including that iAddition operators that we looked at before. If I were to F12 on that, you see that this has a static abstract operator.
Yes.
Right.
Because
of plus.
Operators are really just static members, right?
Yeah.
They're one kind of static members, and all the different kinds of static members can now be abstracted over an interface. You can say whoever implements this, they must have this operator. They must have this static member, like we saw the static property 0 before, and then you use generics to get at those, like we saw in our example there.
I mean, it's a great feature for the generic math domain, which is really kind of what drove us to really do it. But
and before you move away from here.
Oh, sorry. I did move away, though.
Oh, you did move away.
But
that's fine.
Back.
I just also wanted to call out another little language feature that we added, just as we're here, which is that you can now overload your operators, all the ones that in their primitive form have a checked form. You can also overload like the plus operator with a checked overload, and in that case, that's the one that gets picked if you're in a checked context.
Yeah, this is and this was, again, it was something that kind of came out of us trying to implement this generic math domain. That, this is needed to really fill it all out. And you can see that we went a little nuts with filling it all out. As I look at the iNumber again, there's just a lot of interfaces here, and you can see the scroll bar. It really is composed of many interfaces that can be used to define your own numeric types or things that can be constrained on. But there's also something I want to call out that's really interesting, because it has nothing to do with numbers at all.
Right.
But it's just a really great use of this new feature that is static abstract members on interfaces, or being able to implement static members from interfaces in a sense, right? Because you can also have those defaults.
Well, let's have a look, because being parsable, what does that actually mean?
Right. It means to take a string and give me back an object,
an instance of the type.
Yeah.
So a type that's parsable, that doesn't really mean that things of that type have a instance member on them, right? You can't if you walk up to like a a person and say, parse yourself. Well, too late. It's already a person object. What you really want to do when you're parsing something is you want to get a string and then create the person.
Yeah.
So that's usually the job for a static member, right?
Yeah, and I mean, this goes really well into BCL because we have these parse and try-parse methods on our numeric types, but also on things like GUID, right? Which I'm not adding together, but they're also still parsable and can be, and now you could constrain on this interface to be able to, kind of have a little factory method that might, given a string, produce things out of it.
Yes. So this is really good. If we can have a look at that, there's a parse and a try-parse. The parse is the simpler one of them. It's a static method. It's abstract in the interface. So you're telling people who implement the interface, they want to be parsable. Well, you got to have a static parse method.
Yeah.
You take in a string and a format provider, and you return the type of yourself. Like, so the intention is, class C, when it implements the iParsable interface, it will pass itself as the type argument, so that the thing that will be produced out of its parse method is indeed one of itself.
You're going to see a lot of these T-selfs throughout here because they're often, it's about implementing an interface, but I'm actually the generic parameter on this. This is kind of a pattern we've used throughout.
It's so you get strongly typed results, right? You saw the same with the with the addition operator. You don't want to just get some interface result back, because then you lose your strong typing. You want to be where you have, you thread the strong type through the interface.
Well, this is fantastic. So there are other features we could show here. I think static abstract and interface is one of the things I'm very excited about it, because I feel like that whole kind of embedding of kind of factories almost into the language in that sense, right? These static abstract factories is something that I'm really excited to see what people go and do with it. I mean, we've done the generic math piece, but this is something that much more flexible to see what libraries, Nix libraries we see that do very interesting things around serialization and all sorts of stuff that I'm really excited about.
It's super open-ended, right? We thinking about design patterns, for instance, like we saw that factory it was an abstract factory, right? But it was also a static factory. It takes those two classic design patterns and puts them together and gives you something that is, combines the power of both. And I wonder where else people are going to find that kind of application. This is really one that we are going to see uses that we had never thought of, and that are going to just be exquisite and beautiful. This is kind of raw new expressive power.
Yeah. I'm blown away by it. So, all right, let's kind of take a step in a different direction.
Yeah.
We can talk a little bit about. So, we talked earlier about required properties and how we kind of continue to, refine and evolve larger feature areas in the language. Another one that we've been consistently doing that with over many releases, I think most releases, since C#7 is pattern matching.
Pattern matching, which is this gift that keeps on giving, right?
Yep.
In C#7, we added pattern matching for the first time. It did just a few key things, but already then it was like really, it was opening up a new way of working with different shapes of objects that was more declarative and had, less confusing if then else's and casts and so on in it.
Yeah, for me, when we first did it, I thought it was a really great moment of design where we used the is keyword, which was already technically pattern matching.
Yeah.
Right. We were saying, well, if it's this type, well, now is it this type and I can give it a variable, or is it this type and it's length of 2 or something like that. That's something that I feel like that's caused that keyword, which has been there since C#10, to continue to just evolve and get more powerful. We've introduced, and we did the same thing with the switch statement, but introduced the switch expressions. How might I do this? This is a pretty reasonable implementation of this.
Yeah.
But I think it would be interesting to try and do this with pattern matching.
Let's try to do it with pattern matching.
So
essentially, we want to do a switch expression. Instead of all this imperative logic, let's try to go all out and do this declaratively with a switch.
This is the nerdiest way to do it. This is so let's do it this way.
Yes.
Now, to be able to match on an array is a trick, right? I mean, we could match and say, okay, this array has a length of 0 or something like that. But that's
we don't really, up until now, we haven't really had patterns for things that are list-like. You want to talk about the elements of the incoming thing. So that's what we can do now with list patterns. So you can say, for instance, and we use square brackets for that. Is this an empty thing? In that case, return 0. Except
Actually,
it has to be t.0 now.
T.0.
And but then if it has something, what is that? Let's say it has one thing.
Okay, and so we can use a recursive pattern here and say, oh, it's one thing, and we'll pull that first thing out of it using a variable.
var pattern.
A var pattern.
But that could be any pattern in there. We could say if the first one is null, then do this. But we'll use the var pattern here. And then
so,
it's just that.
Yeah, and so then we can just kind of have a contest, I suppose, to see what gives out first, the compiler's ability to process the size of this file or to produce cases for it. And we can just keep on going, right?
Yeah, but that's...
Because this is telling me that, hey, I haven't covered length 3 yet, so I've got a ways to go.
Yeah, so this is not, it's not sustainable to keep adding more things, but we need a way, essentially, to say the rest.
Right.
What we haven't talked about yet.
Right, and so similar to range expressions, we use ... here for that, right? And so that means instead of just the second element, it means match the first element, put it in here, and then all the rest of the things, put them in this variable. Second, we should probably call this something else like rest. And so now this is another array, okay, which contains the rest of the elements.
This actually uses the slicing that we introduced in C#8.
And I can be very clever, and now I can make this recursive.
Yes.
Yeah, that feels good, right? Although one thing I bet you were just about to point it out too, is that it kind of feels like now we don't really need the second one, right?
Yeah, I mean,
if I look,
let's try to swap them around and see what happens.
Yeah.
Now we get an error saying we'll never get here.
Right, because it's subsumed by the branch above. That's awesome, by the pattern above. That's great.
Yeah, so pattern matching telling you, it's doing a more in-depth analysis of what you can do and what, just giving you feedback when your pattern matching is kind of off.
Yeah, I would say that though one thing about this that's a problem is that it's kind of slow. Right, we're allocating. This is now an allocation factory. We're allocating new arrays.
Yeah, this is using slicing on arrays, which is not the best.
But we have ways of doing that.
Yeah,
and we can use a span right here, and then we can come in and also say use a span right here, and now you'll see that on the sliceable, this thing is sliceable, and therefore we can get another span as the rest of it, and we are no longer
slicing spans is cheap.
Yes,
because it's just kind of looking at the same thing. So very cool.
That's very cool.
Yeah.
All right.
There's one little sleeper feature we should get to before.
Oh yeah. Yeah, for sure.
Before they tell us to leave the stage.
I just started a build to show that it does run. All right. Yeah. Next up, then let's talk about this last sleeper feature.
Yeah. So string literals in C#. Great for like Shakespeare. Not so great for JSON or XML.
No. In fact, if I run this, I mean, you could see how it prints, right?
Yeah.
But I had to come in here, when you copied and pasted this, you had to come in and escape these quotes. You can make it a verbatim string, but then you still have to escape the quotes by putting 2 double quotes.
Yes.
Yeah.
No,
it's really annoying.
Yeah. So new kind of string literals that we call raw string literals.
Yeah.
And they are the ones that have no escapes in them whatsoever.
Right.
Delimited by...
Delimited by 3.
Yes.
Exciting. And so you can see, maybe if you look close, you can see that the colorization on these went away, because those are no longer escaping double quotes. Those are now part of the content.
Part of content.
Yeah.
Everything in there is part of the content. But Dustin, that someone would say, what if you want 3 double quotes in your content? What if you paste something in that has 3 double quotes? Then it's going to get confused, right?
Yeah, then it gets confused, and this now ends it, and that's a problem. So in the spirit of C#11, I would say just add one more.
Yes, take it to 4.
Yeah, take it to 4. And so now you can do exactly that.
Always contain any content by just putting more double quotes around it than it needs. Really cool.
We can also make these multi-line by introducing. But the problem with that, or not the problem, but that there's one restriction that this guy has to be on its own line.
Yeah.
And we will clean up the front and the back of that. And so if I come in here and run this, you'll see that this is now multi-line. But this is always annoying too, doing multi-line, because
they go to the margin.
They can always go to the margin. And so if this were in a method body, I would be slamming this against the left side to try and strip the left. Or maybe I was clever and wrote code to do that, which seems also not in the right direction. So, but I can indent these just fine. And if I also, indent the trailing delimiter, you can see this little line, if you can make that out. That's what that's doing, is that's showing you where it's going to trim the left margin.
Yes. So this has a left margin trimmer built in, which you can control with the end curly, the end quotes there to see what it is. So we're out of time.
Here we are.
But we should just mention here, there is a story for interpolation of these guys as well. So you want to copy paste something in, then start poking holes to compute values and insert their string representations. That's all there as well.
Awesome.
Okay. So with that, thanks for watching. Many more C# features. Go and play with it. And if you haven't already, send a quick tweet so that we can get questions here right now from Richard Campbell over there in the corner. Richard, how are you doing?
Nothing like language geeks for breakfast. Hi, I'm Richard Campbell, and we got some great questions for Mads and for Dustin. I'm going to start with this one right here from Jay Sakamoto. It was one of the first questions that came in asking, is C#11's required and init property effective for property injectors, like inject foo service foo of get and init on my Blazor code? Because if I could get rid of the workaround null bang, I'd be a happy person.
That's a very specific question.
Highly specific platform question.
Blazor people want their love, man.
I assume they do. Yeah.
So I would say go try it.
Yeah.
But
I mean, the required
C#11 code is going to C#11 features show up in Blazor.
Yeah. So exactly. So I can't see right here without looking at it whether.
No, it sounds like something you should try. Right.
Yeah.
I'll take it out for a spin.
I would say if you've been writing null bang and that works today with an init only property, I would say it almost certainly works to take the null bang off and do a required property.
Yeah, some code brings you love, Dustin, and some doesn't. And you guys have shown some great things. So I'd be excited to take those all out for a spin. I hope Jay Sakamoto does as well. Let's grab another fun one here. This is from Maran, whose name is Upside Down, and he says, does the C#11 required keyword participate in inheritance too? Is it possible to override it?
That is a great question, because this was like the source of like 90% of our design discussions.
There's a lot of discussion around
Yes, it totally, requiredness is inherited. So your derived class will definitely also require your required things. There is we discussed, to what extent should this be overridable and how granular should that override be? And in the end, we said, okay, we don't know that there are scenarios for very granular override. So we put in an attribute called set required members attribute. And if you put that on a given constructor, then that is exempting that constructor from the requiredness of the member. So essentially you can say, this is a special constructor, like a copy constructor. This initializes all the things, even the required things. So when this constructor is called, don't give them errors for not initializing. That was the override that we picked. We can always refine that later. I mean, that's a C# again already next year, but we want to see solid user scenarios to make that worth our while, essentially.
Yeah, that's exactly right.
So great question.
Yeah, and I really appreciate all the thoughts you guys have on these particular problems. Watching your presentation hit me right away. How many of these features that you get to show today, you've actually been working on for years. I know you put out C#11 just this time last year, but I got to think some of the things I saw today, especially around generics, they've been worked on for a long time.
Yeah, the abstract virtual statics, or the abstract statics and interfaces, that feature was actually prototyped the first time over a decade ago.
Sure.
Yeah. That was back when it was all, the classic .NET runtime, and we didn't have the same ability to evolve the runtime. This really needs tinkering with the runtime itself, not just with the libraries or compiler. We couldn't do it back then, so we had to not do it, but it's been on the radar for that long.
Yeah, and it occurs to me doing the history of .NET work, like generics have been part of .NET since the very beginning. They were part of the original specifications written in the late 90s. So it is cool to see these things still surfacing that were part of the thinking right at the very beginning.
Yeah, I mean, essentially, we're trying to stick with the spirit of C#. The really core ideas that were there from the beginning, we keep trying to refine those, and we keep trying to do our design in the spirit of those, even as we take C# in a direction, certainly, of more terseness and brevity, kind of make it feel more lightweight and more approachable for new adopters as well. We try to keep those core concepts, rally around those rather than, slam things in.
Well, Mads and Dustin, you guys hit me hard first thing in the morning. I'm glad I had a cup of tea early because it got me thinking about a lot of stuff. Thanks so much for putting this great presentation together.